Okay, I was waiting for the video to become clear. In this video, I'm continuing with solving homework 2. As I promised at the end of the previous video, I have solved the problem at the bottom of the page and you can check your answer, the equation of the line. Okay, and let's move on. Now we have a word problem here. Online betting. Okay, so the problem is on online betting. Global casino gaming revenue from online betting was 147 billion in 2012. Oh, global casino revenue. The revenue was 147 billion in 2012 and 183 billion in 2015. Find an equation in that form. This is very similar to what we are doing just before this, but now this is a word problem, right? So we are basically going to we have to read the word problem and create the points, the data points, okay? So this is how I will write from given, okay? The points are this, $147 billion, okay, actually, sorry, that's the output. 2012, the value is $147 billion. And in 2015, the revenue is $183 billion. Okay. Or year and revenue, basically. Data points. Okay. These are the values given to you. Now write an equation that models this information where y is in billion dollars. So the y value, that's why the revenue is in the y value and x is the year. Okay. Now they did not say like year starting with 2012 as your original year or zero. They said the year. So what we have to do here is while you have to be careful with the starting point. Okay, 2012 is the starting value in this case. Anyway, I think the point will take care of it itself. So like before, like the problems that we were doing before, first we have to find the slope, right? Therefore, the slope m is going to be y2 minus y1, 183 minus 147, because y is the revenue, right, in billions of dollars. So y2 minus y1 will be that. And x2 minus x1 will be 2015 minus 2012. 3 years. So that is 36 over 3, that is 12. Okay, so it will be $12 billion per year. That is the slope. We don't have to write the units. I'm just writing for clarity. Billions per year. At that rate, the revenue is increasing. Every year. And now let's write the equation in the point slope first. Okay, using x1, y1 as the point 2012, 147. Okay, y minus y1 equals m times x minus x1. And that gives you y minus 147 equals 3 times x minus 2012. And that gives you y equals 3x Interesting. I don't know if I should have taken that as a value 0. Just a second, okay, I'm thinking here. If I take that as the data point, 3x, where x will be the model year. Oh, okay, yeah, actually it doesn't matter. We are good, okay. So 6036. 6036 plus 147. So your equation would be y equals 3x minus 5900 900 or 800 actually, sorry, 5800 and still 11 more, so 89. 900, 6036. Okay, so that will be our equation. Use this equation to estimate the online betting in 2014. Okay, so once you have the model, it's very simple. In 2014, right, you are evaluating the y value here. Okay, so y will be 3 times 2014 minus 5889, which will be 6042 minus 5889. So that's going to be 111 more and 153. Okay. Therefore, now you write the answer in this sentence. Okay. The estimated online betting revenue in 2014 is 153 billions. $153 billion. Okay. So basically, the question is about understanding that the years are your like x values and the revenue is your y value. Then you take 2 points from the given data, so we can get the equation of the line because we have x1 y1 and x2 y2. We get the slope and then the equation. Then any other question is asked, you can plug in, right? If they ask 2014, that is the x value, so you plug in the value of x as 2014 in the equation, it gives you the y value. Okay, so let's move on to the next exercise. Find the exercise 1.5. Find the zero of the function. By definition, okay, zero of a function means you set the function to 0. The value of x which makes the function 0 is the zero of the function. So that gives you minus 3x minus 12 equal to 0. This is all about solving equation now. Okay. So minus 3x becomes 12. Continuing here, that gives you x equals 12 divided by minus 3, which is minus 4. And that's your answer. Minus 4 is a zero of the function. Okay. Next, solve each equation analytically and support the solution graphically. Okay. Check analytically and support graphically. Let's begin with the first one. Minus x minus 5. I'm going to like, simplify the left hand side on the left, and right hand side is already simplified. Minus 2x minus 5, that is expanding the parenthesis, plus 8x equals 3x minus 5. And if you solve that, minus x minus 2x becomes minus 3x. You have plus 8x. Minus 5 will make it minus 10 equals 3x minus 5. Okay, minus 3x plus 8x will be plus 5x, and minus 10 equals 3x minus 5. And that gives you 5x minus 3x equals minus 5 plus 10. I brought the x to the left and I took the minus 10, which is constant, to the right. Okay, and continuing here, that gives you 2x equals 5. So you get x equals 5 over 2. Okay. Now, checking analytically is the part where you plug in. You take the 5 over 2 in the equation and plug in on a calculator. You can verify both sides by plugging in 5 over 2, and if your answer matches. Okay. Graphically, again, I'm not able to show it on the paper here. On a calculator, if you were to plug in y1 as the left function and y2 as the right function, um, this is like how it is in your note-taking guide as well, right? All the graphs that you see there. This is x, that's y. And what you will see is, for example, the right-hand side is y equals 3x minus 5. And that's going to have a graph which looks like that. Y equals 3x minus 5. And the left side also is going to be some graph. I don't know like what slope it is. Okay, I'm just going to assume, for example, if it was anything, let's say, 1 second, 5 over 3, yeah. So if it was, let's say, something like this, and they intersected somewhere here, right? Or it could be any other line, but suppose they intersect there. The coordinate of that point will be 5, 2 and something. We don't care about x, y value. The x value will be 5 over 2, right? That is the meaning of verifying it or supporting it graphically. Okay, so you literally have to plot the two equations. That whole thing on the left side is your second equation here. Okay, now the other questions I'm only going to solve analytically. Checking the analytically and graphing, you have to do it by yourself. Okay, all right. Now here, continuing, solving this analytically is the important skill I am trying to teach you here, because it involves doing this algebra. Okay, so 6 is the common denominator on the left side here. And let me show you like some smart things we can do now. I can cancel the 1 over 3 and 1 over 3 because they have the same sign and they are on the opposite side. So basically, it is something x minus something x equal to 0, right? It doesn't even matter what they are. Anyway, I'll do it here. Okay, so it will be 5x in the numerator, minus 6 times 2 will be 12x. When you take the common denominator, over 6 equal to 0. Only thing we wanted to check is if the left side also becomes 0, right? Which it did not. So you basically get some non-zero, minus 7 over 6 x equal to 0. 5 minus 12 is minus 7, right? So it's minus 7x. And that only means x is 0. You cannot have non-variable. Minus 7 over 6 is not 0, right? So x has to be 0. Okay. If you have questions about that, or if you do not understand that logic there, please reach out to me. Next. 5x minus 8 plus x. Now here I have to do the parenthesis first, that too from inside out. So I'm not going to do anything with this part here. I'm going to first work on what is inside the parenthesis. Okay. And there you have 5x and 3 minus 13 is minus 10. So that first. And here 6x minus 8. I can combine them, equals 2 times. I have to still work inside here. So minus 4 minus 5x plus 10. 6x minus 8 equals 2 times. Okay. Now this becomes minus 5x plus 6. Minus 4 plus 10 will be plus 6. And I noticed something actually left side. Let me erase it and write it as 2 times 3x minus 4. 6x minus 8, right? I can take 2 as a common factor. And why did I do that? Because I noticed that I have a common factor 2 on the right side as well. So I can now write 3x minus 4 equals minus 5x plus 6. Bring it to the left side, 3x plus 5x. Take 4 minus 4 to the other side, and that gives you 8x equals 10. That gives you x equals 10 over 8, which is basically 5 over 4. Cancel 2 and 2, you get 5 over 4. Okay. Next, classify each equation as a contradiction, an identity, or a conditional equation. Okay. So, three things, right? If you get both sides which are clearly not true, like 0 equal to 1 or anything like that, without x, that is a contradiction. If you get 0 equal to 0 or 2 equal to 2, whatever, same expressions on both sides, then it is an identity. Otherwise, you will get a value of x, that is a conditional equation. Okay. So, and use a graph or table to support your answer. The logic is same. Okay. Um, you can plug in different values of x and evaluate both sides. And if you get the same values every time, that is your identity. If you get different values, then it is a contradiction and so on. Okay. And if it is an equation, you won't know it. You have to do it graphically and you will see that the two lines will intersect. Okay, let me solve this first and I'll talk to you about the graphical thing. What you will see in a graph. Okay. Solving this now, half x minus 2x plus 2. On the left side, after you expand the parenthesis, 2 minus 3x over 2 on the right side. X written like that in the middle goes with the numerator always. Okay. And actually, I said that I could have done this also. Let me write it as x over 2. Okay. Now minus 2 and plus 2 can cancel. And you can check here easily that if you take common denominator here, it will become x minus 4x over 2. And you have minus 3x over 2 there. So clearly you get minus 3x over 2 equals minus 3x over 2, which shows that this is an identity. Your graph would look like this. If you were to sketch this in a graph, okay, your graph would look like 2 minus 3 half x, let's say, is this line. And the right hand side also will overlap, basically, coinciding graphs. that is when it is an identity. It is true for all values of x, so the graphs themselves will coincide. Yes, if it was a contradiction, you would get, now this is for everybody's knowledge, I'm just discussing something extra, okay, not what the question is asking. I don't know where to draw it. Maybe on the top right here, okay. So if it is a contradiction, you will get two graphs like that. Contradiction, okay. And what you have here bottom below here, this is another question, but that's the graph of a conditional equation. Conditional. So for a particular condition, when x is 3, they intersect. They are equal when x equal to 3. That is the condition, right? Conditional equation. Okay. All right. Using the graph at the right, solve each equation or inequality. F of x is less than g of x. Look at the graph. The blue is f, the red is g. So if you want f to be less than g, you are in this territory, right? The blue line is below the red line. And where does that begin? You are writing the value of x here in the solution, okay? And this is going to happen on the right side, right? For the point 3 comma 2. So basically from 3 till infinity. Okay? That is comparing f and g. The second inequality here is comparing just f. F of x is equal or less than 2. Okay? And to understand that, let me first erase this and draw a line. That is point 3 comma 2. So the equation of this line is y equal to 2. All right. So at that point there, the black dot there, f of x is equal to 2. And you want f of x to be equal to 2 or less than 2. And again, if you move to the right, you are less than 2, right? So the answer in this case will be including 2 now. There is a square bracket because it says equal or less than 2 from 2 to infinity. Oh, sorry, 3 to infinity. We're solving for the value of x, not y. Okay, from 3 to infinity, f of x is equal or less than 2. Notice the open bracket and close bracket in the two answers, right? And they relate there because of the type of inequality involved. Okay. Solve each inequality analytically, writing the solution in interval notation. Okay. I think that will be the main work. Graphically, we'll see 9 minus x minus 1 less than 0. And that, if you simplify, becomes 8 minus x less than 0. And that you can write as 8 less than x, or if you turn it around, x is greater than 8, right? You can just flip the inequality and also change the direction of the inequality. So x is greater than 8. If you plot this in a calculator, that's what they meant. Okay, it will show you the, or just a number line. Sorry, you don't have to have x and y. If you just take it in a graph, in a calculator with one variable, it will show you a number line. And 0 is, let's say, here, 8 is here. So from there onwards, right? From here onwards, x greater than 8. It will be like that. Okay. And it says that, if you read the question, once part A is done, the answer to part B follows. And that is because the inequality, everything else is same except the inequality itself, right? Instead of less than 0, it is equal or greater than 0 now. That means I didn't have to redo the whole work. That is the whole point here. Not that actually. Let me take the answer here. And based on this, I can say my answer here will be x is equal or less than 8. Just because my inequality has changed the direction. So my solution also would be exactly the opposite. Now you want to do this in a graph. Okay, actually infinity and minus infinity here. In the graph, you would have 0 here, 8 here, like that. Okay. Solve each inequality analytically and write the solution the same like before. Okay. More practice. Let's do it. Minus 12x minus 8 minus 12x minus 2. Okay. So 12 and 12, minus and minus on opposite sides. So basically you can cancel them out. So this is similar to equation. Okay. You get minus 8 equal or less than greater than minus 2. Now, is that a problem? Think about that. On a number line, minus 8 is more to the left. And we are saying that is equal or greater than minus 2. Minus 2 is more closer to 0. It is to the right. So if you go to the left, it should decrease, not increase. So this is not a proper conclusion. So we say the answer is a contradiction. Okay. And if you have to show it in a number line, there is no solution. Basically, that will be your answer on a number line. Okay. And if you wanted to write this as an interval, your answer would be an empty set. That is called an empty set, a set with nothing, or a number line without anything marked there, right? So there is no solution. Okay. Next one. Now here we have a fraction in the center. So first we need to take care of that minus 5 in the denominator, right? So what I'm going to do, I'm going to multiply throughout with minus 5. Multiply minus 5 times minus 3 and change the direction of inequality because you are multiplying by a negative number, x minus 4 greater than 4 times minus 5. That gives you 15 equal or greater than x minus 4 greater than minus 20. This looks fine. I think we'll have a solution. Add 4 now. 19 equal or greater than x greater than minus 16. You are adding plus 4 plus 4 plus 4. Okay. And your solution on a number line now is going to be from minus 16, 0 here, let's say, 19 here, open side here, close side here. Or if you want to show it, you can show it like this as well. Okay. I have about 9 minutes. So I will start the other video, so I can complete at least in the next one, finally. Okay. Acid mixture. Now we are solving word problems basically. I think this exercise is about solving word problems. Okay, and this will take a while. So let me do the first problem in this video, at least, and we will do more in the next ones. Suppose two acid solutions are mixed. One is a 26% and the other is a 32%. Okay, which of the following concentration cannot possibly be a concentration of the mixture? Oh, okay. This question doesn't require big solving. Okay. I could have uh, just not given so much space there. Logic is very simple. If you mix 26% and 32%, you should get something in between, right? One is stronger than the other. 32% is the stronger solution. 26% is the more dilute solution, a little bit. But when you mix, it will become a new percentage, which is in between, right? It cannot go below 26, it cannot go above 32. So this is possible, that is possible, that is possible. This is the answer. Okay. By the way, I didn't mean to put tick mark and say those are the answers. I meant those are possible. Okay, so answer is this. All right, nothing much to discuss there. Consider the following problem. One number is 3 less than 6 times a second number. Their sum is this. Find the numbers. Okay. If x represents the second number, which equation is correct for solving this problem? One number is less than 6 times the second number. Second number is 6. Sorry, x. X represents the second number. So you're taking the second number x and you're doing times 6 and is 3 less than. The first number is 3 less than. 6 times the second number. 3 less than 6 times the second number. Okay. The sum is 98. Their sum is 98. So you're adding them. 6x minus 3 and x. You're adding them and their sum is 98. Oh, okay. This particular part I might have, like, I don't know whether this typo has come out wrong. Let's assume this number here is 98. Okay. Or the question at 32, doesn't matter. Then your answer would be this, basically. Okay. So the left side has to match, right? Make sure that, the 6x minus 3, that expression you understand. One number is 3 less than. So minus 3, 6 times the second number, which is x according to question. So 6x minus 3. And the sum of the numbers, so the 6x minus 3 is the first number, by the way, and the second number is x, right? When you add them, equal to 98. Okay? All right. So let's look at the next problem. Solve each problem analytically and support your answer graphically. Okay. So we need to solve this problem. Dimensions of a square. If the length of the side of a square is increased by 3 centimeters, the perimeter of the new is 40 centimeter more. Okay. This is similar to one problem from our class. So I'm going to go ahead and do it quickly. Length of a side of a square is increased by 3 centimeters, right? So you say let x, sorry, let the square be x by x centimeters. Or that's not the correct way of writing. X centimeter by x centimeter. Okay, suppose that is the dimension of the square, right? Okay, and by given You increase by 3, x plus 3, then the new perimeter. If the length of the side of a square is increased by 3, the perimeter of the new square. So the perimeter will be 4 times the side, 4 times x plus 3 is 40 centimeters more than 40 plus twice the length of the side of the original square, 2x. That's all. 4x plus 12 equals 40 plus 2x. Oh, is it the same question? I don't know. I'm remembering now. Yes, it is the same question. Funny thing. Okay. You can check the notes as well. Okay. We did it earlier. Find the length of the side of the original square, which will be 14 centimeter, let's say. Okay. Let me try one more. We have 2 minutes. Or there is only one page to solve, so why to hurry? Actually, let me do that in the next video. Okay, so the next video would be just solving these 3 problems. Okay, and I can do that with a good explanation. I'll see you in the next video.